something I haven't mentioned, so sorry about that. Okay, so this actually was the first thing I was going to say today, a little late. When the bending moment function changes somewhere between the beam's endpoints. Okay, so let's give that point a name. You know, let's call it A. So let's say the x value is equal to A. Okay. There are two requirements. The deflection at A according to the left function, you know, the function that represents the left of that point A, is equal to the deflection at A according to the right function. That makes sense, right? I mean, if the deflections aren't the same, if the deflection, so this says that if you have a function like this, those 2 points have to meet. Let me, so like if this is x equals A, this is the left function. This is the right function. So what does this requirement say? It says there's no discontinuities in the beam. The beam stays a single thing, you know? Yeah, like, I mean, it can break, but if it breaks, you're not doing these calculations anymore. You're doing other calculations.
But it's fine if it's like a cost.
Well, according to this, it's fine. But then our next one is going to say, no, we're not allowing that either. So this is no discontinuities. And then the second one says, well, how do you think you'd prevent those cusps from happening?
Same tangent.
Yeah, exactly. So VA prime using the left function is equal to VA prime using the right function. So this is the one that says those slopes have to be the same. This requirement basically just says that it's differentiable everywhere. Okay?
What do you mean by us?
Like this point here. The beam isn't going to have a shape like this. Yeah.
So VA has nothing to do with the bending moment V. It's a different V. Like the V that's part of the equation for, you know, like an M.
Oh, right. It doesn't have to do with the shear force. Is that what you mean?
Yes.
Yeah. No, that's a totally different V. This V is the deflection.
Okay.
And you can think of, so basically you can think of the deflection as the function that gives the position of the beam, because it all starts at 0, you know?
Okay, so that's why it's like the tailed off V.
That's why what?
It has like the V with the tail.
Oh, yeah, right. It's like a lowercase v.
Okay, cool. And then in that formula, the I, so we said so the M over EI equals V double prime.
Right.
We said the EI is the thermal rigidity or something?
The EI is called the flexural rigidity. It's like how stiff it is against being flexed, you know?
Okay, and then that's E, the Young's modulus, and I, the area.
Correct. Yep. So we have two types of moments of inertia in this class. The area moment of inertia has no subscript, and the polar moment of inertia has the sub p, and that's for torsion. So you only use that polar moment of inertia for torsion. Okay. So 10,000, 10,000. This is 2 meters long, circular. Okay. So we have downward force of 10,000 and a horizontal force to the left of 10,000. And I'll call this RA and RB. And does it have a mass or anything? No. Okay, so Newton's second law says RAX, RAY plus RBX, RBY plus negative 10,000, negative 10,000. I'll move that to the other side, so those are both positive then. And then the moment equation, I guess I'll put my about point at the left. So we have negative moment arm of 1 times 10,000. So that's a clockwise moment. And then we have a counterclockwise moment of 2RBY. That's equal to 0. Okay, so.
We have moments from the weld joints.
Oh, those are weld joints. You're right. Yes, we do.
That's not on my first
So call that MA and MB. Okay, so our first 3 equations, we have RAX plus RBX is equal to 10,000. RBY plus RBY is equal to 10,000. And 2RBY plus MA plus MB is equal to 10,000. Three equations, more variables, so we can't solve it. Let's see, 1, 2, 3, 4, 5, 6 variables. Okay, so at this point, we know that this is statically indeterminate. So now we're going to calculate the internal loads. And we don't know what the external loads are, so we're going to have to just carry those variables through. So how many cuts are we going to need here? Two, yep. So cut 1 is valid for x's from 0 to 1. You have the reaction RA, the couple MA, and then just the internal loads. And there's no torque in this problem, so I'll just write it like that. Newton's second law says RAX, RAY plus T negative V is equal to zeros. So T is equal to negative RAX. V is equal to positive RAY. And then the moment equation about the z-axis, I about points at the end. We have MA plus M minus Vx is equal to 0. And so M is equal to negative MA plus Vx. And so M is equal to negative MA plus Y, sorry. Times, I forgot the X here, RAY times X. Okay, with me on the first cut? And now cut 2 is for x's between 1 meter and 2 meters. We have RA, MA. This time we have the two 10,000 Newton forces. And then the internal loads. Newton's second law says RAX, RAY plus negative 10,000, plus T negative V is equal to zeros. And so T is equal to negative RAX plus 10,000. V is equal to positive RAY minus 10,000. The moment equation about Z says MA minus 1 times 10,000 plus m minus Vx is equal to 0. So m is equal to negative ma plus v times x plus 10,000. And so m is equal to negative ma plus rayx minus 10,000x plus 10,000. Okay, those are expressions for the internal loads. And now we have to come up with deflection and elongation expressions. So, okay, on the first cut, so for x between 0 and 1, we know that mi v double prime is equal to the function that we got on cut 1, negative m a plus r a y times x. And so m I v prime, we're just going to integrate these. So negative m a x plus r a y over 2 x squared plus c1. Integrate again. That should not be m, that should be e. This is equal to negative ma over 2 times x squared plus ray over 6 x cubed plus c1x plus c2. And now on the second half, we have e I v double prime is equal to this function, negative ma plus ray times x minus 10,000 x plus 10,000. So ei v prime is negative ma x plus ray over 2 x squared minus 5,000 x squared plus 10,000 x plus c3, and then integrate one more time. ei times v is equal to negative ma over 2 x squared plus RAY over 6x cubed minus 5,000 divided by 3 is 1666.6 repeating x cubed plus 5,000 x squared plus C3x plus C4. And now we have like a million constraint equations that we have to use. So let's just think about what we know. We know that at the left wall, V and V prime are equal to 0. At the right wall, V and V prime are equal to 0. So that's 4 equations. And at the middle, we know that the functions for V have to agree at that point. And we know that the functions for V prime have to agree at that point. So we have 6 constraint equations. Okay, so I'll just list them out so we don't get too bogged down in the algebra. So the first one says at x equals 0, the deflection is 0. V prime at x equals 0 is 0. Now same 2 equations, but at the right end, this thing had a length of 2, so that's 0. V prime for x equals 2 is 0. And then finally, at x equals 1, V left has to equal V right. And at x equals 1, V prime left has to equal V prime right. The first 2 are mathematically the easiest 2. Okay, so our first equation if V is equal to 0, then EI times V is also equal to 0. So I'm not going to bother with the E times I. I'm just going to plug in this function. So first thing we're going to do is set x equals 0 on all of these. And you get, let's see. Remember that since we're doing this at x equals 0, only one of these 2 functions for deflection is relevant. Okay, you can't use the function that represents the right half of the beam. You know what I mean? So we got 0 plus 0 plus 0 plus C2 is equal to 0. Yeah. And I'm just going to keep updating our functions as we go. Maybe I'll just wait and do that. Not every single time. Okay, so our C2 is 0. Now we'll do the deflection equation at x equals 0. So that's this. Plug in x equals 0. You get 0 plus C1 is equal to 0. Okay, so we have E, I, V prime. And this is on the interval, this is only valid for x between 0 and 1. Negative max. So our C1 is 0. Okay, C2 is 0, C1 is 0. So there's our two functions for the left half. And now we'll go to the right half. So our third equation says when x is equal to 2, this has to be equal to 0. So our third function is this thing. So E, I, V is equal to and we're putting in 2 for all our x's. So this is 4, 2 squared. This is 2 cubed. 2 cubed. Two squared. Two, and this is all equal to 0. So negative 2 m sub a plus 4/3 ray minus 13,333.3 repeating, plus 20,000 plus 2C3 plus C4 is equal to 0. Well, we can't solve for either of those, any of those variables yet. So I guess I'm just going to set this aside as equation. Okay, so I'm counting with a couple different number systems, but let's see. So where are our statics equations are these. Now I'm going to call this one equation 4 star. Who's losing contact with this at this point? Anyone? Okay, so now we're going to the numbers everywhere. Okay, now we're going to, at x equals 2, the deflection is equal to 0. So that says EI V prime that is this one, but we're going to plug in 2 for x. So this is 2, this is 4, 4, 2, and all this has to add up to 0. So we have negative 2 MA plus 2 RAY minus 20,000 plus 20,000. Ooh, those go away. Plus C3 is equal to 0. So negative 2 MA plus 2 RAY plus C3 is equal to 0. This is our equation 5 star. And now we have the two, basically we have the requirements at the seams between the two functions. So first we'll do the deflection thing. So this says that at x equals 1, the deflection on the left has to equal the deflection on the right. That means that EI times the deflection also has to be equal because those are the same on the two sides. So I'll just keep that in there. Okay, so where are the updated, okay, here are the updated ones. So on the left, we have this function with x equals 1. So negative MA over 2 times 1 plus RAY over 6 times 1 1 cubed is equal to, and now we'll go to the deflection equation on the right side. We haven't made any updates on that yet. So this is negative MA over 2. Let me just copy it. This is 1 squared now. This is 1 cubed. One cubed. One squared. And 1. So altogether, this equation says negative MA over 2 plus RAY over 6 is equal to negative MA over 2 plus RAY over 6 minus 1666.6 repeating plus 5,000 plus C3 plus C4. Few things cancel. And you get that C3 plus C4 is equal to negative 3,333.3 repeating. And that is our equation 6 star. And now we just have the one left to go, the deflection equation. Anybody have any questions about the line of reasoning here? It's so much algebra that it makes it easy to lose track of the line of reasoning. But the line of reasoning is pretty simple if you can just focus on that.
Could we make it simpler by just solving for C3 and C4?
Do we have a way to do that yet? I don't think so.
Yeah, you could just put above, couldn't you solve for C3 and C4 using, because you could solve for C3. Oh, I guess you can't. So.
Yeah, you could do it in terms of MA and RAY, but let's just wait till we get the whole system. We just have one more equation to go. And then the last one says that at x equals 1, the derivative of the deflection is equal. Okay, so start with the updated one. And this is for x equals 1, so this is equal to I'm just evaluating all of these at x equals 1. So negative MA plus RAY over 2 is equal to negative MA plus RAY over 2 minus 5,000 plus 10,000 plus C3. And you get that C3, this is our equation 7 star. C3 is equal to negative 5,000. And so from that we can say C4 is positive 1666, I think. Okay, so now we've used equation 7 star, we've used equation 6 star. We have the two constants. And now we have, well, we have 5 equations left. And how many variables do we have left? I guess they all, that says 6 variables.
We still have a dot detention.
Oh, yeah, that's right. Thank you. So yeah, this is just the deflection, but we have to also do the elongation.
This would be a really funny example.
Yeah, really funny. Everyone would be laughing so much. Okay, so now elongation. Well, at least this one's easy. So the elongation says crash. T1 times L1 over EA plus T2 L2 over EA is equal to 0. And so, where did we get those? So for cut 1, we have negative RAX for T. Times the length of that first half before where we have to make that cut, divided by EA plus on the second cut, negative RAX plus 10,000. Times the length of that piece divided by EA is equal to 0. So multiply both sides by that. And you get that negative 2 RAX is equal to negative 10,000. And that's our equation 8 star. So now we have 6 equations left that we haven't used for 6 variables. You can solve it using reduced row echelon form. Okay. Any questions about any? I guess the most helpful questions would probably be sort of big picture things, you know, and just you can work your way through the algebra if you're confident in where you're going, but the real issue is just getting confident in where you're going, you know.
Makes sense.
Okay, well, that's all for today. Maybe I'll just change was this due today? I'll just change the due date to Wednesday and you can just carry over the assignment. Okay,
Quick question.
yeah.
So we ended up with, after initial statics, we had 3 equations, 6 variables. Then we found 6 constraints, but we added 4 constants of integration. So that gave us, from the deflection, 2 more equations. And then finally we had the elongation, which gave us 1 more. So that would be 6 equations for 6 variables.
Yeah, that's right. Yeah,
A lot of algebra.
it's so much algebra.
Algebra is good for you, thank you, Mike.
It is, it's like broccoli.
Keeps you smart.